Good evening, everyone, and welcome to the Canberra AWS User Group for August 2021. I'd like to begin by acknowledging the traditional custodians of the land that we're presenting from, the Ngunnawal people, and pay my respects to their elders, past and present. So we're back again. We're in lockdown, so obviously we're back in my house instead of doing this in the office like we would normally do. But we're not going to let a little bit of lockdown stop our user group running. This evening, what are we going to be covering off? We'll be doing our usual run through of what's new in AWS this month. We're going through training updates and white papers. And then we've got Tash here, who's going to take us through a presentation on how to accelerate your machine learning journey with AWS with Amazon SageMaker's latest features. So to get this started, I always like to remind people that we've got a YouTube channel. And it's got a URL there that is not very fun at all, but I can't change that until I get 100 subscribers. So tell your friends about it. We've got a backlog of all of our content there from March last year up until tonight's session. We'll be there hopefully in the next couple of days. So if you've missed something, you want to go back and watch it again, go and check us out on YouTube and make sure you subscribe to our channel. So in terms of what's new with AWS this month, so far there's been 107 new features and releases this month. And I say so far because when we look at it on the chart, because who doesn't love a good chart, it looks a little down this month, but there's still a full week of the month before we go. This just happened to be the last Wednesday of the month, which is when we normally do our user groups. So hopefully that'll pick up and we'll have a look at what that looks like next month. But here's some of the highlights that I wanted to take you through before we got started this evening. The first one is one that is useful for Australian customers here. It's Amazon Kendra is now IRAP assessed to the protected level. So Kendra, if you're not familiar with it, is a intelligent search service that's designed to be able to really easily answer the questions based on the way it searches and indexes content in documents. So rather than saying here's a search result that is a 200-page long document, it looks at the query and is able to help you identify contextual answers based on the contents of documents. So this is a really great way to build some really great search solutions. And now with this new IRAP protected certification for it, you're able to run a protected workload that uses Kendra. Next, Amazon CloudWatch Synthetics supports visual monitoring. So basically what this one means is that you've got the ability to run CloudWatch Synthetics, which will run synthetic requests against your web applications and APIs. But now what it can do is it can take screenshots of your web pages and compare those on each run. So say, for example, I wanted to every 5 minutes make a request to my homepage, and I want to make sure that every request when it loads, it looks pretty much the same. And so what this is going to do is do a comparison of the two images, and you can set essentially a threshold for how different those images can be before it triggers an alarm. So this is a really great way to catch unintended UI bugs or content that's not loading correctly and have your synthetics trigger alarms for you in CloudWatch. Next, Amazon CodeGuru Profiler adds recommendations for the Python application support. So CodeGuru, we've talked about a few times. It's got a reviewer component for doing your code reviews and a profiler component for doing analysis of your live applications. Now, previously, this was only supported by Java, but as of this month, you can now do profiling of your Python applications. So this means CodeGuru can scan your Python applications as they're running and make performance and security recommendations to you about what's going on in those applications so that you can go and optimize them for performance and ideally reduce costs in terms of how you're running them. Another developer-related one here, the AWS CDK, the Cloud Developer Kit, has made a bunch of releases this month, but there's been a couple of updates in particular that are worth calling out here. The first one I'll talk to is the CDK Pipelines module has been made generally available. So this has been in preview for, it's probably about a year now. I forget the exact date that it kicked off at. But this is a really easy way to deploy code pipeline to set up and run your CDK applications for you. So the GA release does have a few breaking changes from what was in the preview, but there's a bunch of things that it enables as well. So if you've been using that CDK Pipelines module, it's definitely time to come back and have a look at the GA version. The second update in here was around unit testing. So previously, the CDK only supported unit testing for TypeScript projects. Now there's a new module that's still in an experimental phase, but it's called CDK Assertions. And this basically means that we can run unit tests in the same way across all the supported languages within the CDK. So if you're a Java or a Go person or Python, you can go and start writing these unit tests on your infrastructure now in the same way as TypeScript developers could be doing previously. So definitely one to go and check out there to improve the stability of your CDK applications. All right, next up, AWS Security Hub has added 18 new controls to its foundational security best practices standard, and there are also 8 new partners for enhanced cloud security posture monitoring. Very long headline, let's unpack that. So the foundational security best practices standard is one of the sets of rules you can turn on in Security Hub. And it's basically just a collection of things that are good security practices to implement within AWS. So that rule set has been expanded with 18 new rules that run across a number of services, including Elastic Beanstalk, RDS, a couple of VPC updates in there from memory. So if you're using this rule set and you've got the option set to automatically include new rules, you'll have seen that they've just turned on in your environment, and now you've got more security monitoring. If not, definitely go back and have a look, because there's some great new things in there to help make sure that you stay secure. Also, there's been 8 new partners added to the integrations with Security Hub. So one of the great things about Security Hub is that you can go and bring in software from partners that you know and trust and have been working with, and continue working with them, but integrate into AWS better, leveraging Security Hub as a single pane of glass to report on things. So with 8 new partners there, that range of partners we're integrating with continues to grow, and it's definitely one to keep an eye on. Next, a brand new service was announced this month. It was Amazon MemoryDB for Redis. So MemoryDB is essentially a sort of customized version of Redis that is designed to be a primary database with a write-through store to Amazon RDS. So previously, what developers would do was you would write code yourself that would query your database and get a response, and then store that in the cache. So you manage writing to the cache, retrieving from the cache, and figuring out if you needed to go and do a query off to the actual database. With MemoryDB, you can actually read and write directly from MemoryDB, and it will handle updating the database for you. So this means that you can simplify the code in your application, and you can get some ridiculously great performance out of this, because it's all based in memory. So you'll get, I believe it is millisecond writes and microsecond reads, depending on the specifics of your query. But because we're in memory, this is what we're working to, which is dramatically better performance than you'll get directly from RDS. So if you've got applications that need that ultra high performance levels, doing it in memory with MemoryDB could be something worth looking at putting into your architectures. Next, Amazon Athena can now write query results in Parquet, Arvo, Awk, and JSON formats. So if you've used Amazon Athena before, which for those of you who aren't familiar with it, is essentially our serverless data querying service, where we can query data in different formats that's stored in S3, as opposed to querying a relational database. But you use SQL syntax to write those queries. So this is a really great way to query things like log files, for example, and other data stores that you might be using in your data lake solution. If you've been using Athena before, you would have noticed that when you run a query, the results are written as a CSV file into an S3 bucket. Now, you can use the Athena APIs to get those results and work with those, or now you could access the files directly. Now, with the option to choose the format we're writing those in, this opens up some interesting scenarios around how you might use Athena as part of an ETL pipeline, where I could run a query in Athena and store those results maybe in Parquet format in a different S3 bucket that progresses things along through my data processing. All right, and the last 3 I'm going to take you through this month. Next one is an AWS WAF update, our Web Application Firewall. Now offers managed rule group versioning. So the managed rules were rule groups that you could just drag into WAF without having to configure the individual rules on your own. So there's a number of managed rules provided by AWS, as well as by security partners that integrate with WAF. Now, previously, you would bring those in and you would just get whatever the latest version of those was automatically. Now, if this is not a model that's going to work for you because you need to test changes before you implement them in production to make sure that a new WAF rule doesn't inadvertently block traffic that shouldn't be blocked, or worse, accidentally unblock something that should be, then these versioning rules will let you go through and choose when you update to a new version. So by default, what will happen is you will stay on the latest version. If you do nothing, you will keep getting those latest versions. You can, however, choose a specific version of a managed rule group, and then you've got the ability to choose when you move from one version to the next. So if you've got a scenario where you need to have that level of control over those managed rule groups, now you can. Next, the AWS App Runner integration has been built into the AWS Toolkit for Visual Studio Code. So App Runner, if you've not heard of it, is essentially one of the easiest ways to take an existing application and run it in AWS. So I can take the code from my web applications, point App Runner at it, and App Runner will handle turning it into a container, deploying it into Amazon ECS, and setting everything up you need to be able to run that application. So it does all the hard work about the infrastructure for you. Now, with the integration in the toolkit for Visual Studio Code, you can easily, from the IDE where you've been writing this code, say, just take this application and let's run it in AWS. So making it even easier to use App Runner as part of your process. And the last update that I'm going to cover off for you today is that AWS cost categories have introduced split charge rules for allocation of shared costs. So this is one that I've seen in a few of my customers over the years, where customers want to do either chargeback or showback to different areas about their costs on what they're running in the cloud. And for things like, an EC2 instance, it's very easy. You say, here's your EC2 instance and it costs X. But sometimes there are things like shared charges that are very hard to attribute to an individual organizational unit. So things like data transfer, for example, and network egress. Now you can go through and define a rule that says, here's how I'm going to split those costs between these different cost categories. And you can do it based on an even percentage, or there's a couple of other modes that you can do to split that out there. And now you can have those costs broken up as per your rules. So it's a really great way in terms of how we're managing costs, where you need to break up those shared ones in your cost reporting. So in terms of training and certification updates, as always, aws.training is the website I want to go to for a complete list of courses and times and what's happening online and or in person in different parts of the world. One update that was sort of technically in the end of last month, but I wanted to call it out again this month because it was very relevant in terms of the main presentation we've got this evening, is that the new ML Ops Engineering on AWS course is available. So definitely one to go and have a look at if machine learning operations and processes there is something you want to get into. White papers that have been released and updated this month, there were 17 of them. So a couple of the highlights that I wanted to call out. So there's a new white paper on AWS Outposts, high availability design and architecture considerations. So Outposts is a great solution if you need to be able to run a workload in your data center, usually for latency requirements. And you want to make sure that it's still going to be highly available. This is a white paper that you would definitely want to look into. The DevOps monitoring dashboard solution was updated this month, and so we've got an update to its white paper. And also there's a new one around hybrid machine learning. And so this is, again, I'm not even going to attempt to understand enough about machine learning here, so if you've got questions on this, fire it to Tash when she comes on. But again, a machine learning white paper that was added this month, worth having a look at. So on that note, we're going to get ready to hand over to Tash and get into tonight's main presentation. So just stay with us for 1 minute and we'll be right back.
Hi everyone, welcome to my presentation on accelerating your machine learning journey on AWS with Amazon SageMaker, and thank you Brian for this intro. Today we are going to talk about a few things, mostly machine learning. I'll take things from a very high level and we'll talk about some of the offering that we have to help you get started on that journey, but also the latest feature and more specifically a deep dive on Amazon SageMaker Data Wrangler. And we'll do a little bit of a hands-on demo. So I just wanted to get started with this image, this background that you see on my presentation, because I think it's quite cool. It's one of the pictures that's been taken by the rover that is currently on Mars, the Perseverance rover. And the reason I put this here is because actually NASA is using the AWS cloud for all of the telecommunication to the Perseverance rover, as well as bringing back all the data, all the telemetry data and all data that's being collected, and it's doing all the analytics of that data on AWS. So it's quite cool. So in terms of the agenda, as I said, first of all, we'll talk about why AWS is a great place to do machine learning and the current state of AI and machine learning. And then we'll dive into Amazon SageMaker Data Wrangler, and we'll do an end-to-end demo with some data that is taken from these Titanic data sets that I'll talk about. And we have a little bit of time for questions if you have any questions at the end. So I just wanted to start with a little bit of background on why Amazon is doing machine learning. Well, it's something that we've been doing for quite a long time, for over 20 years, and it's something that we've been doing in many different areas. So we started with things like personalization, for example, and recommendation on the retail website that you know, this Amazon.com website. And we did that for products. We also did that through the applied machine learning through the supply chain to do things like forecasting, for example. And over the years, we've taken this machine learning that we developed for these core functionalities for the Amazon.com website, and we brought it in the different subsidiaries that we have. So, for example, this Amazon Prime website where we have video recommendation, right? So it's backed up by the same technology. So we applied that to many different subsidiaries, and we also worked on new innovative technologies, so things like natural language processing, where you're now able to communicate in natural language with devices like Alexa. We also did things like the autonomous flight drones with the Prime Air deliveries. So lots of different innovation, but it's not something that we were able to switch on in one day, doing so much machine learning. It's really something that has been a journey over the years. And it's actually something that we think every organization today can do and everyone can do. And so our mission, what we say we want to be doing, is to put machine learning in the hands of every developer. And really, we want to make it easy, we want to simplify it, and we want to make sure that everyone can get started and do machine learning. And so for that, we have this AWS machine learning stack. So it's the way that we see the technology here at AWS, the machine learning technology. And there is 3 different layers. So at the top layer, we have what we call the AI services. And this is what I'll talk about first. This is the services that are really, really easy to use. They're meant for developers, people that don't necessarily have any machine learning experience. You don't need to be a data scientist. It's basically just an API that you can call, and you can send some data, and you're going to get some insights out of it. So we have things, lots of examples, things like Rekognition, for example, which is one of the most famous one, probably where if you think about it, you can take a picture, say a picture of your cat, and you can send that picture to Rekognition, and Rekognition is automatically going to tell you what's in the picture. So for example, it's going to tell you that there is a cat, in which location is that cat, this sort of information. And that's just one example, but we actually have a number of those high-level AI services, and there is some that are, I think, quite interesting to look at because they're quite new and they're extremely powerful, notably around the healthcare. So I just wanted to start by giving a little bit of an overview of this tool, or a quick, very short demo of those tools. So the first one that I think is very impressive is Amazon Comprehend Medical. It's using natural language processing, and it's able to do all sorts of things with text data in terms of extracting insights that are specific to the medical domain. And I'm just going to switch over for a second to the console and actually show you. So here is my AWS console, which I assume most of you are already familiar with. I just navigated to this Amazon Comprehend, and on the side here, you can see that there is this Amazon Comprehend Medical on the page. If you go under real-time analysis, you can see what Amazon Comprehend Medical is able to do. So this is some input text. It's an example of text, and as you can see, there is some abbreviations. There is numbers. There is another abbreviation here for years old. There is some medical terms. So for example, medications, dosage, these sort of things. And so if you pass this information to Comprehend Medical, you send this text and you do the analysis, this is what it's able to come up with. And you will see that it's actually super powerful. It's able to do things like, for example, figure out that this is an age. This number is actually talking about the age of someone. It's able to figure out the profession. But it's also able to figure out all of these medical things. So things like, for example, here you see there is palpitation. It's figured out that it's a diagnosis name. There is things like chest pressure. It knows that it's not only a diagnosis, but that it's also referring to an organ. And then you can see things that are super powerful if you go down a little bit, which is the relationship between different things. So for example, you can see the dosage for the medication, etc. So just to give you an idea of what's possible today, right? So quite a powerful tool. And this is available. It's already pre-trained, right? You don't need machine learning experience. You can just use it. So I thought that was quite a good example. The other one that I wanted to show, which is also quite cool, is this example that's done with Amazon Rekognition, which is this vision tool, this computer vision tool that I talked about earlier. In this case, it's used to detect text on those X-ray images. And out of this text, it's able to, using Comprehend, it's able to identify what we call the PII, the personable identifiable information, and then we can wipe it out, or we can hide it using whatever tool you want. So that's what's available at the high level. Lots of other services. Feel free to have a look. Then at the last layer of the stack, all at the bottom is our machine learning frameworks and infrastructure. And that's where we have things like virtual servers, where we give you access to, for example, to GPUs. We give you access to dedicated hardware, so things like the inferential chips as well, which is a chip that is really, really good to do your machine learning predictions. And we also have pre-baked AMIs that already have all of the machine learning frameworks already installed with all of the, all of the configuration that are needed that are already there. So we support all of the common frameworks like TensorFlow, PyTorch, etc. And so those two layers, the AI services and the machine learning services, are sort of the two extremes. One of them is really easy. The other one is really, it's not that complex, but it's very flexible in terms of what you can achieve. And then in the middle, we have Amazon SageMaker. And Amazon SageMaker is our machine learning tool. It's the tool that we have that is meant for data scientists, that is meant for your machine learning teams to be able to take some data and train their own model, train your own model. And the idea is that in Amazon SageMaker, we support the end-to-end machine learning workflow or life cycle. So for example, it starts with labeling the data. So when you do machine learning, typically you're going to need some data. So that's where we start, labeling the data, all the way to building a machine learning model, training a machine learning model, being able to do that at scale, and then deploy that model into an application or into production and monitor that and make sure that everything is going well. So we support this entire life cycle. So that's Amazon SageMaker. And as you can see in this picture already, you can see that there is lots of different steps on the life cycle. There is definitely lots of capabilities around all of those steps. But before I go into there, I know some of you might be new to machine learning, so I'll start by a bit of a recap on the machine learning process, which is going to be very brief. The first thing that you want to do when you do machine learning is start by framing a business problem. So if I go back to my examples with cats in images, your business problem might be that you have cats that are passing in front of your house and you don't want cats passing in front of your house. So you want to solve that problem. And the way that you're going to solve that problem and frame it into a machine learning problem in this case is say, well, I can set up a camera and I can monitor and I can process the images and try to detect when there is cats, and then I can take some action. So in terms of machine learning problem framing, that's going to be, well, I want to detect cats on images with maybe a 95% accuracy, and I'll be happy with that. And I mean that if I can do that, I can solve my business problem. So what do I need if I want to detect cats on images? Well, first of all, I'm going to need data. When we say we need data for machine learning, it means that in this case, if we want to detect cats on images, we're going to need images with cats in them, so we can train an algorithm to learn what a cat on an image looks like. So the first step is going to be data collection. Then you're going to need to think about integrating data integration. So integrating whatever data sources you have. So in this case, that could be your camera and the model that you're going to train. And then you're going to need to do some data preparation and cleaning. So it could be that to train your algorithm, you know that you need a bunch of images with cats in them. And so maybe you went on Google and you did a search and you got, I don't know, the 100 first picture of cats that came up in the search. But the first thing that you're going to need to do is actually doing some cleaning of that data, because there's probably some results that are not really good, that are not going to help your algorithm. So it could be that, for example, out of those results, in search in Google, you got something like a cat image that was a cartoon image. You might want to clean that. You want to take this out of your data sets, because that's not going to help training your algorithm to recognize cats. So that's the sort of thing that you want to do in the data preparation. And once you've done that, typically what data scientists would do is a bit of data visualization and analytics, making sure that they know what they're working with. And then once we're happy with all that, we want to move on to a step which is feature engineering. It could be for images, it's a bit special, but it could be that, for example, if you're working with text, you want to transform that into a form that is numerical, because machine learning model only understand numbers. And so that feature engineering step is that process of transforming something that is not in numerical form into a numerical form, but also something that is understandable in a numerical form that isn't understandable by the machine learning model. So this part requires a lot of machine learning experience and understanding. This is the part, this part and the next, that require the most sort of skill set. And once you've done that, you have your data, your images of your cats that are ready. What you're going to do is you're going to pass those images through different models. You're going to try all sorts of different machine learning models. It could be that you're doing maybe some deep learning. Maybe you have a model that you built with TensorFlow. You want to use that. Maybe you have a pre-built model that you got off the internet that is built with PyTorch, and you want to try that. So you're going to try different things. You're going to try different parameters for each of those models. And out of that, you're going to get some metrics, some accuracy metrics in terms of how good is it at actually detecting cats. And you can evaluate your model based on that. And that's going to tell you if you're actually meeting this business goal, which is what you wanted to do in the beginning, which is detecting cats in pictures with this 95% accuracy that you determined in the beginning. If it's not able to meet that requirement, if it's not able to meet that business goal, then you might want to go back and circle back to some of the steps. For example, you might need to add some data because you don't have enough data. Or you might need to do different types of transformation for your data. But if it does meet your business goal, then in that case, you can move on to deployment. And then that means that you need to start thinking about a whole lot of other things. So things like, okay, where am I going to deploy that model? I have my camera, but now I need a server that is going to host that model. And I need to make sure that over time it still works well. So I need to maybe monitor it or debug it. And I might need to think about how I can retrain that model over time when I'm collecting more data. So lots of different things that you need to think about in this machine learning process. And that's why we have Amazon SageMaker, and that's why we cover all this step of the machine learning process. The idea is really to try and help at every stage to simplify things, so you don't have to think about infrastructure mostly, or you don't have to think about networking, or you don't have to think about anything that is not actually doing the machine learning itself. So yeah, that's the idea. And as I said, we have many different capabilities. A lot of those capabilities that you see here on this slide at every stage are actually new from the latest reinvents. And there is one that I particularly want to focus on because it's really an easy step to get started with machine learning. It's this SageMaker data wrangler that is here in the prepare stage, where we have some data and we want to do this transformation, this initial transformation of the data. So with data wrangler, we're going to dive into that. So that's going to help you prepare your data. Now, as you can see here, we also support all of the other steps. And I just want to mention very briefly the one that are the most important that you should know when you think about SageMaker. So at the build stage, we have something that's called the SageMaker Studio Notebooks, which is managed Jupyter Notebook, which is a typical environment that data scientists use when they want to do some experimentation with machine learning. So that's one that's very important. We also have the built-in and bring your own algorithms option, which means that we actually support frameworks like TensorFlow or like PyTorch, and you can bring in those models and you can very easily build and develop on SageMaker. We also have this ability to train, the one-click training, but also to train at scale. So being able to do this distributed training with a cluster of machines. If you want to use, let's say you want to use 8 GPUs, we give you the ability to do that very easily in ways where you don't have to think about all of the networking and the cluster setup. So really simplified. And the final capability that I think that is very important is the ability to deploy your model. It's just a few click. And there you can benefit from a lot of things that are really baked in, a lot of components in AWS, so things like auto-scaling, all of the good stuff about security and managing that model properly. So those are the core capabilities of SageMaker. So as I said today, I wanted to do a bit of a deep dive into data wrangler because it's quite easy to understand, and it's also a good place to get started. So to do that, we're going to go through a demo that is going to be end-to-end machine learning on tabular data. This tabular data is going to be the data data. I'll introduce you very briefly what the data looks like. So why do we need a tool like data wrangler? Well, we know that today data scientists actually spend most of their time doing this data preparation. So this looking at the data, cleaning it, organizing it, making sure that it's in the format that's going to be digestible by the algorithm. That's where they spend the most time. And it's typically something that we say is between 60 to 80% of the time. And data wrangler is going to help us, first of all, select and query the data. Okay, pretty basic so far. We support a number of transformations that are very typical to machine learning. So things like one-hot encoding. If you've done machine learning before, I'm sure you heard about one-hot encoding. But if you think about other simpler things, that could be like dropping a column in your data, for example. So all those transformations that we do very, very often in machine learning, we support them. We have a tool within Data Wrangler to understand the data visually, which is going to be creating some graphs really, really easily. And finally, one of the most interesting one that I think is really, really cool, is an ability to create a quick machine learning model where in just a few seconds, you're going to be able to say, hey, I want to try and predict that value. Can you train a quick model? It's going to do that for you. You don't need to do anything else than that. And it's actually going to tell you the type of accuracy that it was able to came up with just by itself. And that means that in just a few seconds, you can actually know if a problem is going to be solvable or not. So a pretty cool feature. So about the data, we are going to use data from the Titanic shipwreck, as I mentioned. This data is tabular data, so it's going to be the column format with some demographic data and passengers from the Titanic shipwreck. And we have columns like the ticket class, the sex of the passengers, the age of the passengers, and the most important one is the survival column, which is the one that we're trying to predict. So we're going to try and use the demographic data to try and predict if a passenger survived or not. So let's get into it. Here we go. Back to the console. I'm going to navigate to SageMaker. So for those of you who haven't seen SageMaker before, this is the landing page on SageMaker on the AWS console. There is, on the side, you can see there is a number of options. So as I said, we support the end-to-end lifecycle. You can see that on the side. And today we're going to use the SageMaker Studio, which is our IDE in the cloud, where you can write all of your experiments, all of your machine learning experiments, but you also have access to all the different components within SageMaker, like being able to track your experiments, but also things like being able to use Data Wrangler. And the first time you set it up, it's just a few clicks. You should be able to go through that quite easily by yourself. And then once you've done that, you'll see something that looks like this, where you have on the side an Open Studio option. And I'm just going to click on that. And I actually already opened it, so I'm directly going to navigate to that, so I don't have to wait. And this is the page that you should land on the first time you open it. So as you can see, this is a Jupyter-based environment, Jupyter Lab. For those of you who have never seen Jupyter, who don't know what it is, let me just show you a quick example of what it looks like. So this is a typical Jupyter notebook. This is a place where anyone can come and write some pieces of code like this in the cells, those famous cells in Jupyter. But you can also write text, so think with Markdown, something like that. And the idea is that you can create this sort of what do we say, computational narrative, where you have some text and you have some cell that is going to execute some code, and you can have some visualization like this, and you can create this narrative and execute all of that in a sequential manner. So that's the 2-minute explanation of a Jupyter notebook. So this is the environment on which SageMaker Studio is based. And we added a number of components to that Jupyter environment. So if I go on the side here of my Jupyter lab environment, and I go to the last option, here we have SageMaker components and registries. I'm going to click on that. And as you can see, we have our SageMaker resources here. I can go on and click on the side here, and you can see that there is all those different things. So for example, endpoint, we have a model registry, we have pipelines, we have a feature store. All those different things are different components of SageMaker, in which I definitely don't have time to dive in today, but feel free to have a look by yourself. And the one that we'll go through is Data Wrangler. So just going to open that, and we are going to create a new flow. So I'm going to click on New Flow here. It's going to open Data Wrangler, and that should be relatively fast because I already opened it before. And the idea is that we're going to create a flow, a data transformation flow, where we get some data, some initial data. We're going to apply some transformation to that data, and then we can run some analysis, like, for example, those visualizations that I talked about, but also this ability to create a quick model. So the first thing that we do is importing some data. And here we have 2 options that actually integrate with other data sources like Redshift and Snowflake as well. But in this case, we're going to use Amazon S3. I'm going to click on that, and we're going to go and get our Titanic data in my Titanic bucket. So Let me just go there. I have a Titanic data wrangler bucket. That's the one where I store my data. And I'm going to use the train.csv file. So when I click on it, I can see this quick preview. So if I don't remember what's in my bucket, that's an easy way to see it, to see my CSV files, for example. We also support Parquet files, but in this case, we'll use CSV. So in this preview, you can see that in this train.csv file, we have this demographic data that I talked about earlier with the passenger class, their name, the sex, the age, and the most important column if they survived or not. So 0 is they died and 1 if it's that they survived. So I'm going to import the data set. I'm happy with it. Let's click on import. And as you can see, it's creating this data flow. So the first thing that it does is inferring the data types. So for each of the column, it's going to try and say, hey, it's a string, or it's a long, or it's a date, etc. I'm not going to go through that because it usually does a good job with this data set, but you can go and change that if you're not happy with what it did. So let's add a couple of transformations. So if I click on the plus sign here, you can see that I have access to a few things. I can add transformation, I can add analysis. Let's try and add a first transformation. So I'm just going to close this so we have a bit more space. So this is my data. And on the side here, I have all the transformations that are available. So as you can see, there is things like the ability to manage columns or row, where I can drop column. So in this case, for example, I see that there is a name column. That's not going to be really useful to my model because I want to use the demographic data to predict if someone is going to survive or not. So I'm just going to drop that. So let's say I want to drop that column, and the name column that I want to drop is name. I can create a preview. I see that it's removed it. I'm happy with that. I'm going to add that transformation. Okay. Pretty cool, that was easy. Now you can see that there are things that are very specific to machine learning that, for example, you can encode categorical variables. So that's something that you typically want to do if you have this type of data where you have categorical variables, like the class, for example, here, where you don't want to keep it as a hierarchical sort of numerical values, because that could infer some meaning for the model. You want to move that into something that doesn't have this hierarchical meaning, numerical meaning. So what we're going to do is we're going to transform that. We're going to one-hot encode it, this P class column, and I'm going to choose column at the output side. Not going to go into too much depth here, but basically this is what I'm going to do. So you can see that it's removed the column from here. And if I go to the end of the data set, it's added 3 different columns here, which have this, my class for each of them. So I'm happy with that. I'm going to add that transformation. Pretty cool. So easy to add transformation. If I want to add custom transformation things that are not supported natively, I can go and type in some code here. It supports pandas, PySpark. You can just write a little bit of code to do this transformation yourself, your custom code. So pretty cool. I'm happy with that. That's my transformation. So as you can see, I'm going back to my data flow. Now I have my source in S3. I have my inferred data types, which I didn't touch here. And then I added those 2 steps of transformation. Now, say I want to add a quick analysis of that data. So I'm going to move on to add analysis. And the first one that I want to do is, if I look at it, I would like to have a quick visualization of the data. So we're going to do a quick histogram. So here I'm selecting histogram in the analysis type. And we're going to call it, doesn't matter, actually, let's just leave it at that. As the x-axis, I'm going to select the age. At the color, I'm going to select the sex of the passengers. And at the facet, I'm going to select if they survived or not. So that's going to draw this histogram. So if I click on preview, let's give it a second. Hop. You can see the results here. And so you can see that you have two facets. So you have the passenger who died on this side and the passenger who survived on this side. You can see that the orange ones are the males. And so you can see that mostly the passenger who died were actually males, which correlates with the story we all know. And the passenger who survived were mostly females, as you can see here. And you can see the spread by age as well. So very quick way to do an histogram. I mean, I literally started this this demo a couple of minutes ago, and we already have this this histogram, and I didn't need to go and Google how to do a matplotlib for 15 minutes. So I'm pretty happy with that. The last functionality that I want to show you is this quick model functionality. Or if I click on it, it's going to be able to do to train a quick machine learning model for me in just a couple of seconds. So in this case, I'm going to call my analysis survived, like did passenger actually survive or not? And I'm just, the only value that I'm going to specify here is the column that I want to try and predict. So this column here, if they survived or not. And I'm going to click on preview. That's going to train the model in the backend in a couple of seconds. And it's going to tell me right away the type of accuracy that it's able to come up with. So you can see here that the model achieved a 0.8 F1 score, which is actually a pretty good score. And that means that actually this use case seems feasible, right? And so I might want to pursue that and move on to using, bigger and more complex machine learning models behind the scene to try and implement that use case. But it means that basically it's doable. And the other thing that I can see here is that it came up with this important sort of diagram that shows for each of the columns in my data, which are the ones that have been used that have the most importance in terms of making a prediction. And so you can see that the sex and the cabin are the two most important features to make a decision in terms of if the passenger survived or not, which also correlates to what we know from the story. So yeah, that's the idea for Data Wrangler. So you can do all of the things in just a few clicks. And once you've done all of that, you can go back to your data flow. Say, I'm going back to my data flow. If I'm happy with all the transformation that I applied, for example, and the result that I came up with, what I can do is actually export that flow. And that's, so say I want to export all of it. Up, I can click on export step, and I can directly generate Python code, for example, that is going to do all this data transformation without me having to rewrite all the code. But I can also do other things like save the processing to S3 or export it in the feature store. So many different things possible. But that's the idea for Data Wrangler. And that's pretty much all I wanted to talk about today. And if you want to get started on your machine learning journey, before I drop, just one thing that I wanted to say is that we have lots of tools to build your skills and trainings that are available online. So for example, there is this training that Brian mentioned at the beginning of the call on MLOps, but we also have courses on Coursera, on edX to train you up in the skills. And we also have these hands-on learning tools like the Deep Racer tool, which is teaching you how to build and not really how to build, but how to train an autonomous car and try it. So lots of different things that are available for you to build your skills. So that's all I wanted to cover. And we are going to hang up to hang around here and look at the chat to see if there is any questions from you, and we're happy to answer. And I'm going to hand over to Brian.
Alrighty, thank you so much, Tash, for that presentation. I definitely learned a thing or two about Data Wrangler in there and the Titanic. So good night all around. So as always, we love feedback, and we want to know what you all want to hear. So leave us messages through Meetup or in Twitch, or find me on Twitter at Brian Farnhill. Just let us know if you have topics you want to hear about, or if you're interested in doing a presentation. It can be even just 5 minutes talking about something cool that you learned, or something that didn't necessarily work so well that you wanted to talk to people about. Always interested in hearing from people in the community about what they're doing with AWS. And speaking of feedback in general, please do submit it every month. So if you registered through Meetup, then you'll get a notification through Meetup saying, hey, rate us. It's just a quick 5-star thing and a couple of quick buttons. We read it every month, and this helps us figure out, are we getting you content that you actually want to hear about? So please do submit that feedback. If you haven't found us through Meetup, go and sign up to Meetup, because you'll get emails about when we're planning presentations and what the content is. So definitely go and check us out on Meetup there as well. And lastly, tell your friends. Friends don't let friends miss the Canberra AWS user group. Word of mouth continues to be the best thing in terms of spreading what we're doing and letting people know about the fact that we're online, we're live on Twitch, we've got the YouTube channel. So send some links around to people if you like what you've seen tonight. But other than that, thank you for spending some time with us again. We will be back again next month with more of the usual AWS goodness. But that pretty much wraps us up for this evening. So thank you for spending your time with us, and have a good night.